Good morning, everyone. This is the first video lecture. We are just recording it, and any trial basis actually. If whatever the your input is, that will definitely rectify in the second video lecture. So, as a demo lecture, I am considering one fact of a video bandwidth that is 5 megahertz. So we have to realize this, how this 5 megahertz is, and what is actually the video bandwidth is, and what is its relation with the horizontal resolution. With this point, there are certain questions which have been asked in the exam. So under this horizontal resolution and video bandwidth, straightforward questions are: define the vertical resolution and horizontal resolution. So you have to compare it and contrast between the vertical resolution and the horizontal resolution. Then we should know the proof that maximum video frequency is equal to 5 megahertz. So this is very important for you to realize. From the derivation point of view, anybody can ask you that what is a video bandwidth, and if it is a 5 megahertz, you have to prove it. Fine. So let us go for this video bandwidth first. So we in the last in the class we have seen with respect to the Kell factor what it is actually, that if a Kell factor is 0.7, the total actual vertical resolution comes to be like, we multiplied Kell factor number of the active lines and the Kell factor, if we take 0.7 and the active lines which are 585, that is comes to be around 409.5 lines. So it is decreasing the number of the lines when the Kell factor is used. So that point we have to consider in calculation of the video bandwidth. So 4.409.5 is terminated into 409.5 is equal to 410. So what we can say, the number of lines available for vertical resolution is equal to now 410, because we have truncated, we have taken 410 instead of the 409.5. So in moving ahead with the video bandwidth, we should know that the number of vertical lines required to obtain equivalent horizontal resolution. Now these two words are very confusing. I am saying vertical lines, again I am saying horizontal resolution, but it has got a meaning. Fine. So what we say, we have to ensure the horizontal resolution. That is our aim. Means we have to resolve the picture horizontally, and in that we have to consider in a same order the number of the vertical lines required to obtain an equivalent horizontal resolution. I repeat, we want to realize the number of vertical lines which are required to have an equivalent horizontal resolution. And how it comes then? It is a product of what? Aspect ratio multiplied by the number of the lines. So what we have aspect ratio then, it's a product 4.3 multiplied by 410. So that comes to be around how much it is? 546. So 546, that consists of vertical black and white alternating lines, as we know. So the number of the cycles of black and white alternation is equal to how much then? We have to divide it by 546 divided by 2. So 546 divided by 2, it comes to be how much? 273. So we have a value of 273. And in India we are having a which system here? PL lines, PAL, phase alternation line system. And how much is that? Lines are there, 625 lines. So the frequency of the horizontal scanning will be how much? That is FH is equal to 15,625. So this 15,625 is again one of the CCIRB standards which will be requiring. So at present we should know horizontal scanning or line frequency FH is equal to 15,625. So from this what I can get, we have the FH value. So easily we can calculate what? TH. What is TH? TH is nothing but a time taken by an electronic beam to scan one complete horizontal line. Now this is very important. We are calculating what? How much time one horizontal line takes. In other way, I can say that how much time is taken by the electron beam to complete one complete horizontal line. What does it mean? That we have studied trace, we have studied retrace in the in that particular point, so we have to calculate the trace time and the retrace time. We are not mentioning over here, but it's a fact. We are calculating technically trace period and retrace period, right? So the time it comes to be of that traversing of that electron beams come to be about 64 microsecond. That is nothing but th is equal to 1 upon fh, that is equal to 1 upon 15,625. So that comes to be around 64 microsecond. Now out of this 64 microsecond, a time period of 12 microsecond is reserved for the horizontal blanking. So horizontal blanking means where there is no picture, it's a retrace part, so that 12 microsecond is a reserve for that. So I want to calculate trace. Trace is nothing but a forward scan period. So forward scan period is equal to what? 64 minus 12 is equal to 52 microseconds, right? So we know the 52 microsecond. Technically it's trace forward scan period is equal to 52 microsecond. Horizontal blanking time is equal to 12 microsecond. 52 plus 12 is equal to one horizontal line, and its time is 64 microsecond, right? So in diagram we can also see in that complete diagram is given, and the diagram's label is what? Horizontal forward scan and a blanking time diagram, right? You can draw the diagram, and the name of the diagram is what? Horizontal forward scan and a blanking time. Technically it is a trace diagram and a retrace diagram, that's all. Now as far as the one cycle goes on, now where this one cycles business is coming up, now the number of the cycles of black and white lines is equal to 546 upon 2. We have got a 273 as I discussed, right? So in the notes we have to see, you have to refer the notes. In the video I have not giving you the detail of it. I am explaining the entire stuff of it which is already in the notes. I am just, this is a video lecture. With this video lecture you while my listening you can take down the notes and you can go through the notes also. So one cycle is equal to 52 into 10 to the power minus 6. Where from we got it? We got it from what? 64 minus 12, 52. So one cycle is equal to 52 microsecond upon 273. What is 273? It's number of the cycles of black and white alteration. So if you have this, how much it comes? 52 multiplied by 10 to the power minus 6 upon 273. You can take the calculator and you can calculate. It comes to be 0.2 into 10 to the power minus 6. It is nothing but a 0.2 microsecond. So that is a maximum fundamental video frequency will be given by what then? It will be 1 upon 0.2 into 10 to the power minus 6. That comes to be about the 5 megahertz. So maximum video frequency is equal to 1 upon one cycle upon 1 upon one cycle time. That is how much? 0.2 10 to the power minus 6 that comes to be 5 megahertz. That is 5 to 10 to the power 6. So the maximum fundamental video output frequency of video bandwidth for a vertical resolution is 410 lines, and horizontal resolution of a 546 lines is equal to 5 megahertz. So this is a proof of video bandwidth is equal to 5 megahertz, right? So this is the first technical point we should know, a very important point, that video bandwidth is equal to 5 megahertz. Then we will move to the next slide, which is called as CVS. What is this CVS? Is technically it's a composite video signal. This is one of the most favored question. If you see the history of the question paper, maximum times it has been appeared in different ways and in different formats. So one I will just tell you: draw the composite video signal with a label. Then draw the composite video signal showing all the details and explaining the following thing. The first one is DC level, then is blanking level, whiter than white level, and the other is pedestal height. So these are the things which has been asked. Another one is it also asks enlist the two salient features of this composite video signal. So let us go for this composite video signal right now. This is the second part of this video lecture. So now we will take into account what is CVS. So as far as the diagram is concerned, we should know the diagram, that is on x-axis what it is and on y-axis what it is. So obviously on x-axis we will find the time, that is given into microsecond. Everything will happen in microsecond, right? Then on the y-axis we see that is relative amplitude. So the amplitude, we are drawing the waveform, definitely there will be the amplitude in the on the y-axis, which will be given into the percentage form, right? So as far as the from the diagram we have to realize, we should have the notes in our hand, and also what I am speaking in this video lecture, you have to note it down, and once you note it down and once you see the notes and read it, then it will be a very good synchronism of my video lecture and our notes, and that will pipeline to your mind to write and understand the correct answer. So what is a CVS actually? So from the diagram, without referring anything of the composite video signal, what is available from the diagram, depending on the previous knowledge, let us find out it first. So x-axis, we know what it is. We are having the on x-axis we are having the varying amplitude, that is of a active time for a one line, that is horizontal line, that is of a 52 microsecond. So you can see the amplitude is varying for the 52 microsecond because picture information is present, and you can see that arrow, there is a picture information. Because this picture information is varied, therefore the horizontal line is 52 microsecond. Another one is a pulse is there. The pulse is around 12 microsecond. So we should know what is a 12 microsecond, that is retrace, and this 52 microsecond is a trace. So what is a horizontal blanking period? It consists of a front porch, it consists of a horizontal synchronizing pulse, and it consists of the back porch. So it is a summation of three things. For front porch is equal to 1.5 microsecond, horizontal synchronizing pulse is equal to 4.7 microsecond, and the last one is back porch, that is 5.8 microsecond. So if you make a summation of these three, you will get a value of a retrace, that is 12 microsecond, and rest is the two pulses. So from the previous knowledge we have realized the diagram without knowing anything as such, that what is this actually. So we have just identified what is horizontal line, that is trace, that is a forward scan. Another one is just horizontal blanking period in the form of pulse and in the form of porches, that is front and back porch, and we made a summation of it. So 52 plus 1.5 plus 4.7 plus 5.8 is nothing but a 64 microsecond, which we have visualized in this particular diagram without knowing anything of the CVS. Now let us go for the technical theory part. So composite video signal, what is this then? So composite video signal is defined traditionally. What it is? It contains the intensity information, horizontal retrace and vertical retrace signal. So intensity of light is carrying that information, and that is what horizontal retrace signal and retrace signal. This is a combination of these two, and that is added in the form of composite video signal. So composite video signal is equal to video signal plus synchronizing pulse. Video signal plus synchronizing signal is equal to composite video signal, right? So what it says, composite video signal is obtained. How the production goes on? By adding what? Electrical video signal, right, which is produced by the camera tube, right, and synchronizing signals. So synchronizing signal plus the electrical video signal produced by the camera tube, and plus inclusion with some horizontal blanking interval, we get a CVS, right? So CVS is very extremely important as far as the reproduction of the picture is concerned. Fine. So diagram we can see over here. So now CVS will carry the picture information in the form of a continuously carrying signal amplitude. So the all time the amplitude is going to vary. So due to the negative amplitude, the negative modulation is adopted by the CCIR system, that is B system, where you are using a negative modulation, and the peak of white is represented by CVS with a maximum amplitude of 10%. So on the y-axis time, and just we go to the 10, 70, 75 and 100. So we can understand the level of white. We can understand the white of level of 10%. Black is at 70. Again, blacker than the black it is 75, and 100% is a synchronizing one. So the black is represented by the maximum relative amplitude is equal to 75%. We can see here the synchronizing pulses is presented by a 75%, which is black. and the blanking pulse amplitude is 75%, and the sync pulse occupies 100% relative amplitude, that is blacker than the black. Right. So what is DC level then? Next points are considering what a DC level is nothing but a average brightness level corresponds to the average value of the complete frame. What it is? It's nothing but a average brightness, and which corresponds to the value of the complete frame. That is DC level. What is blanking level? The 75% level, that is blanking pulse amplitude, is known as a blanking level, because blanking pulses are inserted in this level. So here blanking level means what? Where there is no picture, and we are inserting the blanking pulse as the blanking level, because blanking pulses are inserted at that particular level. What is whiter than the white then? The peak white. What is white here? Nearly 10%. So the peak white is represented by what? 10%, as black is represented by 75%. So the peak white is represented by 10% level of CVS, right? So as a negative modulation, it is being used in the picture transmission, the CVS amplitude that are less than 10% whiter than the white. So we have to understand the concept of a negative modulation. For this positive modulation, negative modulation, what we have studied earlier over here. So here we can just realize, due to the negative modulation, right, we are using what? Negative modulation in the picture transmission. So CVS amplitudes that are less than the 10% represented by the whiter than the white signal. So you can imagine that in between white and 70 there lies the picture information. So this was with respect to the composite video signal. So this was the first attempt of the video lectures, right? So we will be meeting very soon in the second edition of the video lecture. Please convey your response. Whatever it is, I will accept it and try to rectify as far as my capacity is. Thank you for being with me. Thanks a lot.